Hello, my name is Larry, and today we're going to demonstrate how to work the Plasser tamping machine GRM 3000T. In previous videos, we learned how to set up the machine for work and using the AGGS system. Now we are going to see how the machine works and how to rectify the line. To start, check to see that the lining indicator on the B9 panel is at or very close to the center. You want to start out with no line throws. Check to see that the right and left lift meters are not showing a lift indication. If they are, you can enter values in the lift section of the work screen on the PLC to remove the lift indication. Ensure the correct line reference is set, located on the B52 panel, and correct 0 point is set. 1. Press the tamping push button to the on position in the tamping screen. Ensure the auto cycle push button is selected. 2. Close the rail clamps that are going to be used. If using rollers, switch the roller close switch to close the rollers. Use the clamp screen and touch the individual roller buttons to close each roller. Use the clamp touch panel to select close to get started and switch to relax after establishing a lift. If using the hooks, in the normal operating process you would use the rollers. It has enhanced lifting capabilities. We use hooks when tamping a switch or if there are track joints. Select half or full for the opening position of the hooks. Select head, base, or down. Head position is selected if neither the down or base button is turned on. Select the depth for each hook, whether it is the head or the base. Manually close the hooks on the rail. The hooks will open and close on the rail automatically with each index and cycle start. 3. Step on the tamping unit's down pedal or pull back on the joystick located on the B52 panel and hold it down or back for the duration of the tamping cycle, which is: the tamping units will go down, the lift will start, the lining will start. The tamping units will come back up to the ready position when the cycle is complete. The work brake will release automatically. 4. Turn the index speed adjustment on the B51 left-hand control panel clockwise to start the machine moving forward. When the tamping units again get in the position over the next tie, release the tamping unit's down pedal or joystick and then step back down on the pedal or pull back on the joystick to start the cycle all over again. Repeat until tamping is complete. As the machine progresses along the work area, adjust the lifting preset in the work screen up at a linear rate to obtain the desired lift. In most conditions, a lift of 1 1/4 to 1 3/4 inch is ideal, and usually one insertion per tie with 1 second of squeeze time will properly compact the ballast under the tie. If the tamping tools squeeze against down ties and they fail to come up, then another insertion should be made. For lifts of 2 inches or more, 2 insertions may be necessary. Minimum lifts should be greater than any cross-level errors in the front of the machine. To set the squeeze time, go to the work screen, adjust the squeeze time in the tamping section. The top of the blade of the tamping tool must always be just below the bottom of the tie, approximately 1/2 inch when tamping. It is preferred that the ballast be removed from each side of a full or a new tie in order to visually check the depth of the tamping tools at insertion. To set the depth, select a reading in inches to the nearest tenth for the depth setting on the work screen. That will give the required travel distance of the tamping units. The tamping tool depth is measured down from the top of the rail. Monitor the progress of the tamping with the lining indicator, work area pendulum indicator, and the rear pendulum indicator on the B9 panel. The lift meters on the B9 panel should come up to the 0 position during each tamping cycle. Anytime the machine is first set up for tamping, a check should be made that the lining indicator is at or close to the 0 reading. Inside the cab, verify that the lining preset is reading 000 and that the lining 0 point controls are set as outlined in the zeroing procedure, which assures that equal throws will be made to eliminate track displacement during actual lining. If all points are correct but the indicator is not close to 0, either of the following things may be done. Tamp only until the lining indicator comes close to 0 and then turn on the automatic lining switch. Back up, but only a short distance until the lining indicator comes close to 0 and then line only until the tamping point is reached. The first method is best utilized when starting from scratch at a new location, while the second method is best utilized when a new line reference rail is selected. Should a line swing exist or engineering stake work is in progress, the indicators may not be close to the center. This should be explained to the operator. Manipulate the lining preset to read 0. If the machine is AGGS equipped, ensure that no alignment values are being generated by it. Select the line reference rail desired. With the lining system set up, index the machine forward on the best available section of tangent track. Adjust the 0 point on the diagnostic screen as needed until the line indicator needle swings equally on either side of the 0 position. Select the opposite rail and repeat step 4. Keep the 0 point control at these settings for future work for the line rail selected. There are 2 ways to control cross-level changes, manually and through the AGGS computer. For manual operation, turn the cross-level reference switch to the grade rail position and adjust the cross-level preset to read the elevation value. When tamping a spiral, adjust the cross-level preset at a linear rate. The reference point for elevation is always the lining buggy. When first starting to tamp, verify the cross-level indicator is at or close to a 0 reading. If not, only one situation will require operator attention, and that is if the grade rail happens to be a lot higher than the opposite rail. In this case, it may be necessary to start main lift utilizing a below 0 setting and disabling the rear feeler rod correction input until the run-up brings in the cross level. If the grade rail were lower, the lift run-in would take care of the elevation run-in. The best way to control cross-level changes would be to utilize the AGGS. Here you would use a measured file that has been solved and ready for work. The AGGS would provide the output signals to the lift and line servos that control the clamp frame. You can add or subtract to the output signals of the AGGS through the controls in the work screen of the PLC touchscreen. Thank you very much, and you can follow up with my next video on YouTube.